Alrighty, so I'm going to start with we're just going to do more worked problems in chapter 4 today. At any time, if you have questions, ask them. I'm going to try to do some different problems than the earlier session. So that way, if you want, you can go back and watch that one later. I think earlier today we did problems 4.16 and 17, and then some old test questions. So I'm going to try and start this time with 4.15, then maybe 4.20 or 4.21 or something. And then maybe we'll look at some old test questions too. And what we did mainly was we focused on what type of problem is this? How do I set it up? What's my knowns? What's my unknowns? What are the keywords in the problems that are going to help me solve this problem? And then rather than do all the algebra, I leave that for you guys to do at home. So it's just kind of focusing on the physics part, not the algebra. Obviously, there's some physics in interpreting the answers as well. So, but that's all done in the workbook for you. All right, so let's, and let's see. That's right, 8 weeks. Oh my gosh, feels like eternity. All right, let's go take a look at a problem. All right, so we haven't done a lot of conceptual problems on this chapter yet, so let's go ahead and do one. So let's take a look at 415. And what I'm going to do is I'm going to give you guys a minute to look at it, just kind of wake up and get used to it. It's a Monday. And then in a minute, I'll ask you about it. And so, if possible, maybe try not to look at the solutions just to see. If you already looked at them, it's not offending me at all. Or if I'm too slow, I understand. Maybe I'll get it drawn up too. Just getting it drawn up, almost ready to talk about it. Okay. So we're supposed to rank vert, velocity, component, initial speeds, and probably time of flight. Yeah. Okay. So I got this drawn up here. In this case, we've got path A, path B, and path C. And the picture indicates they'll go up to the same height. So who wants to take a stab at it? Anybody that feels like it, just unmute and go nuts. Let's try part A.
So I think for part A, A has the highest initial vertical velocity, and then B is next, and then C is next because
Okay.
of how quickly it gets to the max height.
Okay. Now, let me ask you something. Let's say I turn this board sideways and all you saw was the side version. They'd all go up to the same height, right?
Right.
So from this angle, if you were just watching there, would you be able to tell the difference between the three throws?
No, I guess not. Just look like it's going up and down.
No. So what does that tell you about? Now, maybe you could tell one's coming towards you more than the rest, sure. And maybe that's what you were kind of hesitating about. That I agree with, yeah. But so does that make you rethink what you had to say about the vertical velocity components?
I mean, yeah, I guess from that perspective, I wouldn't really be able to tell, but
And so
yeah,
maybe let me go like this. Remember that the horizontal motion has no effect on the vertical motion, right? They're independent from each other. So based on that, yes, they're different x in the x direction a lot. Are they any different if you just isolate the vertical motion? No. The vertical motion, they all go up to the same amount and down the same amount, right? Sneaky, isn't it? So all same.
It's hard to separate that in your brain, you know, that X has nothing to do with Y. When
Exactly.
I initially did this
Yeah.
problem, I did the same thing. I was like, it just didn't come to me until I read the solution. I was like, oh,
Yeah.
That makes perfect sense.
And so one of the things that's really good about conceptual problems is the more concept problems you do, usually the fewer mistakes you make in writing down your initial lists of crap in problems. So that was a pretty good one. All right. So now, I don't know, was that Jacob earlier?
yeah,
Yeah. So I think what you were basically talking about was this one, right?
yeah.
Clearly,
Yeah.
C is faster than B is faster than A, right? So this
Right.
one, they all have the same Y, but C has more X. So again, because velocity initial is equal to V initial X squared plus V initial Y squared, there, whereas here, we're just talking about V initial Y, right? So they all have the same V initial Y, but this one has the most V initial X. So which one of these two terms is going to help us understand the time of flight?
A, because they both hit the same max height, so they have to have the same time of flight.
Exactly. And which that makes sense with this now. Well, this one covers a lot more distance. Yeah, but it's moving faster, just not any faster in the Y. And so, all right. So that's kind of a fun warm up to get us thinking today. All right. So, all right. Let's see what else we've got. Well, actually, let's look and see if the solution tells us anything that I thought was kind of fun to look at here. And yeah, so that's pretty much, I think we covered all that stuff. You can see I screwed up an apostrophe there, but whatever, good enough. All right. Like I said, I thought this was a really good problem. I did this in the earlier lecture. So if you really struggled, you could check out my live stream from earlier today, which is labeled under October 12th as well. So that said, I want to try a different one. And so, let's see. Why don't we try 420? That just seems like a lot of fun. So I don't know why I do this, put all this effort into drawing a guy shaking his fist at someone throwing rocks at a gong, but yeah. And the elaborate, let's might as well have some fun with this. Let's really zoom in on this cheesy figure I drew in Microsoft Word. Look at that ornate blindfold I drew there. Very, very classy. So here's the idea. Oh, look at those motion marks around that arm. I put some time. Oh, the little explosion. Yeah. Nice brass color on the gong too. So here we are. This person's throwing rocks at a gong all day. All right, that's the point. And let me see what's in the chat there. Oh, good. So let's take a look at it then. All right. So if it was hurting your brain, that means maybe I can actually be useful. So let me get it back up on screen there. Okay. Try it blindfolded. You throw this at some angle above the horizontal. So, okay. I'll let you guys write it up on your board. I'll write it up on mine, and then we can start talking, okay? Oops. This is 4.20. Impact. Oh. Ugh. Just drawing the picture. Could use some color. H, we'll throw it at a known angle.
Are we assuming in this question that it's hitting the gong at the top of the curve?
Yeah, yeah.
Okay.
Because you hear the ball hit the gong. So we know it's going to hit the gong, and we're going to assume it basically hits right at the corner. Oh, and that tells us something else. We know this distance right here. All right. So hopefully you had a second to look at that. So this is how I viewed it. I'll maybe get that lower. So we're told that this height is little h, this height is big H, and it hits the gong, which I'm assuming is right there at the corner. The building has height H, capital H. So all right, what are some thoughts? What might you write down when you see this type of problem?
Start writing knowns and unknowns so we can get it down.
Nice. Okay, give me a second. So while I'm writing down the crap to fill in the table, you start thinking about what's going to go in each slot. Because if we can get this table, usually we can get the problem. If we can't get the table, we almost never get the problem. All right. Whoops. Scoot back just a hair. There we go. All right. So anybody that feels like it, go ahead and give me something. One of these things.
Delta Y is big H minus small h.
That's right. So this time, the initial height wasn't negligible. You had to remember that. Good. Somebody else, something else.
Delta X is X.
Yep, not too bad. What else we got? Anything else?
So acceleration in the x is 0, and in the y is negative g.
You're assuming this is a standard projectile problem. Excellent. Unless otherwise specified, we assume this is true and this is true. Good. Sorry, that glare is just kind of annoying there. All right.
We don't know speed, but we can assume that Vix is V cosine theta.
Exactly. So here's something that helps. We don't know what V is, right? We don't know V naught. But I do know that this side right here is V naught cosine theta, and this side is V naught. I'll get out of the way in just a second. We don't know what V naught is, the initial velocity or the muzzle velocity or whatever. But we do know that this is true. Now, what is the advantage of doing that? Think. Theta is a known. What we have just done is we have created a constraint between V initial X and V initial Y. This part is known and this part is known. Now, instead of having two things we don't know, initial X and initial Y, we've rewritten them so there's only one thing we don't know, which is V0. Does that part make sense? That was the big trick in here. And those of you that said you were working on it last night and it was blowing your brains or whatever, maybe that's kind of key. If you could get that, the rest is just writing equations, I think.
But
All
that's
right,
why.
so then
that's
let's
why
see
we
what
could.
else. Go ahead.
I was gonna say that's why we can't figure out the final velocity, right? Because we don't.
Yeah, let's get to that. Okay, so this one I hope you agree is the same. If AX is 0, V initial X and V final X are the same. Similarly, if AY was equal to 0, these two would be the same, but whatever. So I don't think we know this. I don't think we know that. I think we're done. I didn't see anything that told us the time. Did you? No. Time for a nap. That's what it is. All right. So at this point, you could start writing down equations. Well, you know what? I'm going to try going to the solutions just because I've run out of room on my whiteboard already. So my apologies. Oops, we're a couple pages down. Ugh. Okay, here it is. So notice what I did. Here is the X equation. Oh, and just to make our problem match up, I just want to point out on the whiteboard, I said V0. In this problem here, I just called it V. So V, V0 are going to be the same for this case. I apologize there, okay? So, all right. That said, we could just stick it in like this with the annotator. There we go. So now this matches what we wrote on the board, V0 sine theta and Vx. All right, so now I take the X equation and I solve that for time. Again, why am I doing that? Time is something I don't know, and it appears in the delta y equation. What I can do is I could take this and stick it in there for time and get rid of t, the unknown, and replace it in terms of x, which we know, theta, which we know, and v, which is what we're looking for in this problem. Let's clear that and say that all one more time. This is just the delta x equation. I solve that for t because it eliminates the unknown t. I take this and I shove it in for t right here and right here. When I do that, t, an unknown, no longer appears. And look in this equation. Delta y is known. Sine theta is known. X is known. Cosine theta is known. G is known. X is known. Cosine theta is known. Everything in there is known except for the letter V. Now, if you're feeling clever, you might notice this is the trajectory equation that I told you a few days ago. Let me show you what I mean by that. If we go back a few days.
It's the plot of its course, right?
Yes, that's the one that plots out its course. Notice that equation. Why would you bother memorizing this when you see how easy it is to derive it? So this is the equation that I just wrote out. Now notice a couple of tricky things here. Here, I wrote it with y final and y initial. In that problem, I said delta y equals. Also, notice the velocity drops out in this term. Let's go see how that happens. So that's the trajectory equation. Let's go back to it. Notice you get a v right here that cancels this v right here, and that's why the first term doesn't have any letter v's in it. Okay? And again, comparing this, the delta y, that's the same thing as like y final minus y initial. And that's why we get h minus h. So it looks very similar to that. It's basically the trajectory equation y of x. All right. So now I just want to point out, let me get that equation on the board and show you some steps, okay? So I'm going to get this equation written down.
So the thing that was like blowing my mind was trying to figure out which, like I solved for time. I did that just fine. And then I was trying to figure out how to find v final y. And I didn't know which equation to use. And I don't know how the solution manual just decided to use the third one. And I mean, I'm trying to like brain that out, but I'm
yeah. Give me just a second. I'll go through that for sure. So it sounds like this part was all okay for you. It was the next one. Got it. So let's go through that in just a sec. Okay. Whoops. All right. So we get this equation. So if, again, just pointing out, this is known, this is known, this is known. Everything in here is known except for that. So now it's just doing algebra to solve for that. If I move some stuff over, I might move this over and move that over. So gx squared over 2v squared cosine squared theta. Notice it's squared, not just cosine. Should equal, if I bring this to this side, that should equal x tan theta minus delta y. Okay. Now I could go ahead and flip both sides. And I'll move the whiteboard in just a second. All right. All I did was just flip that. So I flip both sides. This becomes a 1 over. And notice you have to do 1 over the whole thing. So now it's easy to just multiply by all this junk. Well, I get a 2 and a cosine squared in the basement. And then up top, I'm going to get a gx squared. And then I have a squared here, right? Well, at that point, I'll just stick a square root on this thing. And you could write it prettier than that. Maybe I'd put some parentheses around here or reorganize it. But that's the basic idea of how you could solve for v. Now, I said you should always think about your plus minuses. Why is this one positive?
because we're throwing it up, right? So
what does v stand for in this case?
the initial speed.
Speed, which is positive.
Yeah.
That's why. Okay. Not because you're throwing it up. So v initial y is positive because you're throwing it up, but speed is positive because it's just positive all the time. Whether you throw it up or down, the speed would be a positive number. So now let's get in there and see. It sounds like that part was all okay for some students there. That's good. So launch speed v, that's why we do that. Okay. Now, to get the final speed, you could see I chose this equation, and that you were wondering why I chose that one. Is that it?
I was wondering why we chose the equation for the initial speed. I did part B fine. It was the part A that I was having issues with.
Oh, why did I choose this one? I see.
Right.
So what I was thinking is, okay, I don't know the final, I don't know time, and I have to get the initial involved because the variable that the problem asked about appears in the initial equation. So let me go back to the question here. Whoops. Give me a sec. Notice what it asks me about. It says the launch speed of the ball. So that's asking me about this velocity over here. When it asks me about that, I know I need to involve some equations that have that in it. So I just write down my same equations that I always do. And these are the first two that I usually write down just in case they happen to work. So when I do that, notice, the initial velocity is going to appear in those. That's what gives me a clue that maybe I should try this. I see that, I guess what I'm saying is this. I know delta x. I don't know v initial, and I don't know time. I know delta y. I don't know v initial y. But I get the same unknown, and I do know this one. So at first, it looks like three unknowns, but then I remember this is v naught cosine, and this is v naught sine, and then I'm like, wait a minute. I really only have two things that I don't know, v naught and t. I see two equations, the same two unknowns, v naught and t. That's what gave me the idea to try that. Does that make sense?
Yeah, I'm just wondering if there isn't also another equation that you could have used, or if this is absolutely the one that you should have chosen.
Let's take a look. So let's see. We also know there's v initial x equals v. Well, this is the only useful equation for the x direction. Do you agree?
Yes. Yeah.
So there's a good sign that you have to use this one. But now if we go to the y direction, and the reason is if ax equals 0, v initial x equals v final x, that doesn't really help you because you still don't know what it is. Let me check the chat there. Okay, Kev, I'll get to that in a sec. All right. So now what if I write down v final y? Well, that one, if I'm going to use it, I don't know v final y. I don't know v initial y. I do know plus 2a sub y delta y. That might work, right? Now, I don't know this. No, wait, I do know this, and I do know that. Well, let's check. What if I use the other equation? V final y is equal to v initial y plus a sub yt. Well, I see that I still have another unknown. I don't know the time, plus I don't know this one, and I don't know this one. So that's not going to help me get anywhere right away. So you could see that you're going to have trouble unless you make this clever observation right here that I'm putting a star next to. Unless you see this, you're not going to get this problem done. So you have to know that this is a trick that sometimes if the angle is given to you, you need to immediately write this and this. Otherwise, you're going to have too many unknowns and you'll never solve the problem. I don't see another way jumping out at me. I'll say it that way.
So
it's kind of the same thing as splitting up delta y or delta x into initial x and final x. You're taking vi, or you're taking initial velocity and splitting it up into
Absolutely.
Speed. Yeah.
Yeah. Yeah. Jake, is that good on your question?
Yeah, can I just clarify just real quick?
Sure.
So the other ones, it actually has v final y and v initial y. V initial y is the same as v naught sine theta,
Correct.
but v final y would be v final sine theta. So then you actually have two
Exactly. Because and it wouldn't be the same angle either, would it?
No.
We don't know
Okay,
the impact angle. This could hit it going up, it could hit it level, it could hit it going down. So yeah. Good?
Yeah. Thank you.
So yeah, v final y would be v final sine of some other angle phi, not theta, and it could be plus or minus, right? Depending if it's going up or down. All right.
Okay, perfect.
Good. All right, so now let's go back to that solution. And now, so now, do you agree, once we know the initial speed, we actually know v initial y and v initial x? Now, they're really ugly, but if you know what v is, everything in here, this is a known. This is a known. Known. So everything in here is known according to the problem statement. Right? So in this case, now if I scroll back up here, if theta is given, I also know this. That means I know v initial x and I know v initial y. So I think it was Kevin asked a question, why would I use this equation? Well, let's look at it. At this point, now I know v initial. I didn't before I did part A, but now I do. I also know AY. I also know delta Y. That means I've got this, and this. And that's why I chose to use this equation, because I have everything except for that. So I think, Kevin, if that was you, was that your question? Does that address why I chose that? Check the chat. Yeah. Now notice, if I want to find the impact speed, it doesn't really matter. I'm just going to get, I don't know which plus or minus I'm going to use, but I know if I'm doing the speed, I'm going to square it out anyways. So v final y squared, I don't even need that square root. So that gives me this big blob right here. And then we see, notice, let me do it this way. You have v squared cosine squared plus v squared sine squared. Well, that's the same thing as v squared times the quantity cos squared theta plus sine squared. And so when I do that one, well, cosine squared plus sine squared, that's one hopefully you have memorized. If not, now you do. It's 1. And so we get this crazy looking thing. Oh my gosh, that's a crazy looking mess. That's the impact speed. It's not really that bad. It looks a lot worse than it is. It's the same thing we've been doing forever, but you have to kind of take a deep breath and patiently work through the algebra slowly and just be like, okay, it's ugly. I might have to write a little bit. So what? Sometimes test questions have this ugly of an answer. That's usually more in 161 than this class, but yeah. I guess I should be careful here. One thing that I didn't do that I probably should have done, I should have replaced this delta y in both cases with h minus h. Right there and right there. Just because that, technically speaking, is what the variables were written as in the problem. I didn't tell you delta y in the problem statement. I told you capital H and lowercase h. All right. So that's a bunch of algebra. Okay, fine. Let's take a look, though. Whoops. Let's get that last question. I said there are two possible final velocities of the ball. But wait a minute. We just found the speed. What the heck? What's the difference here?
Well, if you were talking about velocities, it's either going to go up or down, and the square root would have had a plus or minus technically. So, I mean, we don't know if when he threw it, it just like straight up went up and hit it, or if it went up, hit a max height, and came down and hit it, right? So
Exactly. Of course, why can't he just look at it? Or she? Oh, that damn blindfold. So now that was the purpose of the blindfold, was if you can't look at it, you can't know whether it's on its way up or on its way down as it hits the gong. So if it's on its way up as it hits the gong. So Jake, great answer, by the way. Good job. If it's on its way up, you know V final Y would be positive. If it was on its way down, V final Y would be negative. In terms of the solutions, this gives two possible solutions for V final Y. So the velocity up or down based on this plus or minus. And if you're blindfolded, you don't know. You can know that it hit that spot because of the gong, but that was it. So that was the whole point of this silly blindfold gong thing. All right, so there we go. All right, how's everybody feeling? Doing okay on these? Hopefully doing somewhat okay. So for the rest of the day, I'm going to go out and look at some old practice tests. And what I want to do is I want to show you the question, give you a minute to look at it. And I want you to think, what chapter is this? What technique should I apply? What should I do? What should I start writing down? And I don't necessarily want to do the whole problems. I want to focus on, can you correctly identify the problems? Because that's what I can help with the most. Algebra, to be honest, you guys can do the algebra on your own, right? I know the book can help you with most of that. And obviously I will help you if there's still questions. But yeah, that said, let's rock. Okay, let's let this rip. So again, showing you how to get to those tests. Remember, it was in a Canvas modules. Let's start from the old ones, oldies, and let's just work backwards. And again, just to remind you, here's the test. We're going to look at Fall 16 2A. Here's the solution. So let's go take a look at this one and see what we got. So in theory, you could do every problem on this test already, right? You've done all the learning that is required to do chapters 2 and 4. So let's see. We kind of just talked about that. So let's skip forward. Okay, that's fine. Okay, let's take a look at this. What chapter is this?
2.
Chapter 2, right? Plots. All right, so let's keep going. We want to focus on chapter 4 right now. How about this one?
It's chapter 3 in the workbook, 1 in the book, I think.
This was,
It's 1D motion.
Ask you this. Is this a graphic problem, 1D motion, 2D motion, etc.? Or is it a vector problem?
It's a 1D motion.
Right. And so that was chapter 2 in my book or chapter 3 in the OpenStax. So that's fine. And then here's another one. Very similar. Let's see what we got here. Ooh. So this one, it looks like I mixed it up on the moon. And I tried to stress this in really big font because if you weren't reading that, you would screw this up and just think it was standard problem. So let's take a look at this one. I'll give you a second to take a look at it. Let's go 30 more seconds and then we'll talk about it. All right. So how would you approach this problem? What would you do? Anybody?
Start writing down knowns and unknowns.
Right, exactly. Write down knowns and unknowns. All right. And so in this case, what are the knowns? Is this a standard projectile problem?
Yes, except for the gravity, I guess.
Okay, I'll take that. Yeah, it's almost standard, except gravity is different. So how would that affect your list of knowns and unknowns then? So I'll start writing the crap, and then you guys are going to tell me what it is in just a second, okay? So you guys think. Maybe I'll just do it right over here. All right. So what are some things we know then?
So we know delta x is x.
Okay. Somebody else. What's something else?
We know velocity is v.
Which one?
Both. Oh, for x. Sorry.
Initial or final?
Both.
Okay. Okay. And then what else do we know? Maybe somebody other than those two. They've been doing all the heavy lifting all day. And you could respond by chat if that's easier for you. I'll bring up the chat box so I can see. X is 0. Excellent. All right. Is time known? Anybody see if time is given? Oh, probably not, because it says determine time to impact. So I'm going to assume time is unknown. There, I did my part. V initial y is 0. Excellent. So if it's initially moving horizontally, that implies it's not moving vertically. Nice job. All right. Good. And so notice he remembered the minus sign there, right? Is V final y known or unknown?
Unknown.
Yeah, I don't see it anywhere. How about delta y? Is that known or unknown?
That's what we're asked to find in part B.
Oh, yeah, part B. All right. So at this point, after that, do you agree the problem is basically solved? You just do some algebra, do the same old crap?
Yes.
Hopefully that. And before I move on to the next problem, anybody have any questions about any of those write-ups? We see that basically once you know what the problem, once you know what is given to you, and this is classic in physics and engineering, you at least could say, okay, this is what I have to work with. Give me some equations and start working through it and try to do algebra. All right.
I can't see how. So could you go through just how you would solve for final velocity?
Okay, so time at impact, we're probably going to do a probably, let's see. I would get time from the x equation first. Let's see. Do we know that? Because we know x. How about I write it like this? I just have to get a running start at x equals vt in this case. Agreed? So in this particular problem, since I know that, I know t is equal to, what is it, x over v, if I don't screw it up. So that gives me the time, which then I'm going to take that, and this, for part B, I would probably use the delta y equation, since we now know the time. and I would take this time and shove it in there. And then for this one, I could use v final y equals v initial y, which is 0, plus a sub y, which is negative g over 6, times time, which is x over v. And then I also know v final x is already given because ax equals 0. And then I would say v final is what? How would I get it? Oh, sorry. Yeah, Esteban asked. I'll let him try it. What do you think?
The square root of v final minus.
Is that what you were going to say, Jake?
Yes.
Both of you are good. Does that make sense? Is that what you were asking about, Esteban?
Yeah, I was just trying to use the other kinematic equations, and because it has initial velocity and final velocity, I couldn't. But if you use that one, x equals vt, then it becomes much simpler.
This one? Well, this one goes to 0, and then you get plus 2 a sub y delta y. You could use this because take a look. Once you know delta y, you could plug that in, and then you could get this, and that would work as well. Agreed? So there's 2 different ways to do it. I don't know why, but a lot of times if I can get the time, I'll do it. And then for me, it's just a lot easier to think in terms of, oh, I'll just plug in the time and get some stuff. Because I know how to get x or y just by plugging in t, and I know how to get velocity by just plugging in t. Now, how do you get the angle?
So by that point, we know v final y, we know v final x.
Mm-hmm.
So then we can use tangent to get the angle.
Sure. And what would I probably ask you to do before you do that?
Draw the angle.
Draw. Just yeah. Okay. And so that way you don't accidentally screw up x and y in the tangent. You know what I mean, Jake?
Yeah.
And so he's absolutely right. He's saying, well, we know the 2 sides of this triangle, and I just like to draw them. And I would point out that on a paper and pencil test, usually I make you draw it. This was an old test. This was actually a pretty easy test. Do you agree? It's probably pretty easy, but oh, there's a tricky. Okay. So here, yeah. So you're going to have to figure out that angle and express it some way. That's fine. All right. And so there's going to be an inverse tangent somewhere. I'm getting too many drawings. I got to clear some of this crap out. So, ooh, this is kind of fun. Let's look at this one. If a second ball rolled off the roof with twice as much speed, what do you think? I'll give you a minute.
Wow.
Oh, go ahead if you think you got it.
So time was x over v. If it becomes double the speed, then it'd be x over 2v. So half the time.
All right. What do you guys think? Anybody else? Do you like what he said or not? Or I guess, do you agree with what he said?
Isn't time related to the y coordinate?
Yes.
So it'd be the exact same time?
It would be the same.
Oh.
So, because watch out, I told you it travels distance x. Where the fault in your logic lies is if it goes twice as fast, it's also going to go twice as far horizontally, but it'll still travel the same amount of time. Right? So remember that the time to impact is given by, we know that delta y is going to be the same, and that's going to equal 1/2 g t squared with a negative, right? Because the initial y is 0, and this doesn't change. This doesn't change, so the time won't change. What you were saying is if you go twice as fast, let me put it like this. Delta x would be 2v times the time, but the problem is delta x would no longer be x, it would be 2x because it's going to go twice as far. Does that make sense, Jake?
Yeah.
Sneaky. The concept questions are sneaky, aren't they? So make sure you actually do them. If you have a book where you're reading them and there's concept questions, by all means, do them. I got to sneeze. Hold on a sec. Ah, that's better. Whew. All right. So let's kill that one. That was kind of sneaky, wasn't it? That was the fun part of that question. All right. Is there anything else? Oh, some more plotting stuff. Okay, some more plotting. So it looks like this one. Oh. So I made this one a little bit easier on the kinematics and a little bit harder on the vectors and the plotting. So I could see there's a lot of plotting questions on here. And then, okay, so that's just scratch paper. So if you're thinking, man, that one seemed pretty easy, you know, in this particular test that year, it looks like some of the graphing questions were harder. Look at all these graphing questions that are in there. So, yeah. All right. So there's the, okay, so that's fine. That looks like a good one to review for concepts, actually. There's a lot of good concept questions about graphs in there. So that's a good one. Let's go back. Let's try this one. A little bit more recent. So obviously things have changed since then because the number of solutions I have in my book has dramatically increased since then too. So plus you guys are online and I know you guys all have all of my solutions. So I have to put something a little bit different in there. So that's why I'm teaching a little bit differently, but okay, you probably recognize this one. I put this one in the workbook after everybody missed it. I'm like, oh my gosh, I thought that was going to be straightforward. It turns out it wasn't. Let's keep going. There's another one, looks pretty similar. Some velocities and stuff. Okay, some good concept questions. Ooh, this one was a surprisingly good question. What type of problem does this look like? I'll give you a second.
1D.
1D. Oh, how could you tell? What's the thing that gives it away?
Purely vertical motion.
Yep, purely vertical motion. If it's purely vertical, we don't have delta x. Okay, in that case, what's the velocity at max height?
0.
Yeah. Is it always 0 at max height?
Yes.
No. Only if purely vertical. So maybe Esteban was saying for a purely vertical problem, it would always be 0 at max height. Is that what you meant, Esteban?
Yeah.
But if you throw it at an angle, the velocity at max height would be v initial x in the I hat, right?
Right.
Okay, just making sure. And sorry, it's just Zoom. I'd rather be thorough. Okay, so I think you guys could do that one. Ooh, this one looks good. I like this already. Some kind of evil skeleton zombie. Ooh, a zombie drone. You know we got to look at this one. If you got zombies and drones, how bad? How could this problem possibly be bad? All right. I'm just giving you a second to look at it. Okay. I'll give you just a little bit longer to read it. Another 30 seconds here. All right. So what are you thinking here? What type of problem does this look like?
I'm imagining it's a relative. What is it called?
Relative motion?
Yeah, relative motion.
The relative motion? Turns out it's not that. It's a good guess.
I didn't finish reading the problem, but just because it involved the drone, and then I was trying to write down the knowns and unknowns.
Oh, I see. Yeah. Well, let me ask you this. Did you ever write down this list of knowns and unknowns for a relative velocity problem?
Oh, yeah.
Yeah, so that's your clue. This is basically, it's something out of chapter 4 because it's 2D. Is this standard or non-standard?
It's non-standard.
Yep. Okay.
It has a acceleration on the x-axis, right?
Yeah. What's the acceleration? So since you're speaking, I'll let you do it. Sorry, I'm just making this a little bit smaller so I can get it in here.
I had just seen it. Scroll.
Okay. So what are some knowns and unknowns here? Oh, sorry. Need me to scroll down?
Well, I know the...
So we know the acceleration in the y is 0. So VIY equals VFY.
Okay. Esteban, do you agree with that? You were the one that was asking about acceleration.
Yes.
Yeah. So what's AX, Esteban?
It is negative A.
Nice. So it's not A. The size of it is A, but the direction is opposite the arrow in the system. All right. So now we're kind of off to the races. We see this kind of stuff. So everybody take a minute to kind of think. Let's see if you could fill this in. And you can see on this test, I'm just like, let's see if they can even write this down without doing the math. And and people bombed that. Yeah. So I made this worth 2 points, just seeing if you could write down what's known and unknown, and people had trouble with it. And again, assume we want to get the max horizontal position of the drone. All right, so do we know what delta X is? Yes or no? And if so, what is it?
Negative D.
No, we don't know what it is.
That's what we're looking for. You're thinking perhaps of part C. Do you agree? Esteban? I got to sneeze. Whoa. Excuse me. Esteban, in part C, the horizontal displacement relates to D. So in this problem, D is the initial distance here, but that's not where it's going to turn around, right? It's going to be right over here at some random spot.
Oh, okay, I see.
Is that cool?
Yeah.
So the trick was you're supposed to know that's unknown. And then do we know what delta Y is?
So I guess if we're talking about like in part A's context, we don't, but in part
Correct.
C's we would.
In part C, I don't know if we know it either.
Oh, horizontal. Yeah, so we don't know it.
So we know this part right here is H. And this right here is delta Y. There's no reason to think they're exactly the same or related in any way. So one just happens to be where it started. The drone happened to be right there. And now when it comes all the way back, I could call this delta Y prime, just as meaning like some other delta Y or something. That would not necessarily be the same as the initial delta Y or H. So they could all three be different heights here. No reason to think the delta Y's are related.
You can say that VIX is or VFX is 0 then, right?
Aha, that's 0. How do you know that?
Because if you think about it, like if it was going up and down, it would be the same thing as max height.
So what were the key words in the problem statement that gave you that clue?
Where it wants the maximum distance from the zombie.
Max horizontal position. That's what tells you that. Do I know the initials or not? Were they given?
Yes.
Yeah, well, so in this case, I gave you V and theta here. So that's known. And then somebody said, I think it was Jake earlier, maybe said that this is the same as V initial, right?
Yeah.
And so then I think what we said earlier is we don't know what delta Y is, and I don't think anything has told us anything about time. So we see a typical problem has 3 question marks, and there we go. So I think probably a better question for part C or maybe part D would have been, what is speed as it passes over the zombie's head? That's what I should have asked. I think that's a more fun question. How would you approach that question if I'd asked that?
So V initial X would then be 0 because we're starting from the max. And then we have to find V final X.
So let me make sure I understood. Jake, you're saying you would start from right here and then go over to there?
Yeah.
Yep, you could do that. Could you also start from right there?
Yeah.
Yep.
Yeah, because you have D as the distance from the zombie.
So if you started there, you could actually say, oh, well, doesn't that mean this is negative D? But what Jake's saying is, well, I'd already know delta X here, so I'd know this distance right there. So I could just say my delta X would be this big distance, and that's a nice, easy problem too. So there's lots of correct methods. Both of those ways are right. Let me get some of that out of there just because it's getting so busy. Okay, so that would work. And then what would you try and solve for first in that 6D problem? If you want the speed, yeah, time. Mm-hmm. All right, and so I think we pretty much beat that problem to death. All right. By the way, now you know what an oral exam would feel like, right? It's this kind of stuff. I'd just be like, well, what would happen if I'd asked this instead? I should have asked that. And you'd be like, oh, I don't know. I'd try this. I'd try that. I'd say, what would you write down first? Tell me what you would do. Give me your thought process. Just keep talking to me. Talk so I can understand what's going on in your brain. So if you were freaking out about the oral exams, We've been doing oral exams all day. It's not that crazy. And so the more you speak up in class, the more comfortable you'll feel during that. So those of you, I know it's weird, and who knows what your connection, your situation is like with the internet, but if you can kind of force yourself to talk more, like I mean, let's face it, Esteban and Jacob are talking all the time. Jose did a good job on chat. Kevin's brought up some questions and stuff. And all of you guys have done a little bit. But the more you talk in class, the easier it will be. You'll just feel more natural. You'll be used to me being a punk. And you'll be like, oh, he's probably just messing with me. Let me think. Oh, and you just, yeah. So try to speak up in class if you can. All right. Let's go back there. We've got 4 more minutes. What can we get done? Let's take a look. Was that the last question? Oh, so here was one where then I did one with numbers and one without. So you could see this one, I did lots of work on the 2D motion. So some of them had numbers, some of them had non-level, some of them were standard, some of them were non-standard. So you could see, I guess this one was more about just writing down the list of knowns, seeing if you could get it right. And this one was about plugging in numbers. All right, let's go back and do one more. Hold on. Let's go see what the other one looked like. This one. Okay, some graphing crap. Looks like some relative motion crap. Let's take a look at this one. All right. All right. So I gave you a second to look at this. What would you write down, or what would you think? And if you're feeling brave, maybe some new students could try and speak up. And if you're the ones that's been speaking up all day, maybe just wait 1 minute. And if you want, you could keep working on your own. You know where the solution is. Is anybody feeling brave and want to speak up? That's cool. Okay, so go ahead. Anybody then.
So I started drawing student A, and I drew in the first quadrant like something close to a 25-degree angle with 7.5, and that's relative to the Earth.
So was it closer to the vertical axis or closer to the horizontal?
Closer to the horizontal. No, vertical.
Yeah, exactly. So you start at north, and then you go 25 degrees west of north. So that's the angle. Immediately, what can you tell that's going to do to all of your numbers for that? What do you have to remember now?
Is west the other way, or?
Oh, yeah. Hey, man, east is the new west. Sorry.
Oh,
thanks, Memo. We both spaced out. I was testing you. Very good, Memo. You passed the class. Oh.
All right. I'm out of here. No, I'm kidding.
Yeah. Oh, no. Whoops. Oh, crap. Where's that? Okay, there it is. So here's north. We both did the same thing. I'm tired. All right. So here's west of north. Oh, my gosh. So notice, even when you've been doing physics 20 years or 30 years, you're still going to screw up once in a while. And so the more you practice, the fewer bonehead mistakes you make, which gives you room to make mistakes on the really hard questions. That's a good thing to learn. Everyone is going to screw up. So you have to try and practice to minimize your screw ups. Thanks, Memo. So there we go. And I'm running out of room here. Let me just squeeze that in there. Meters per second. So notice the vertical component gets a cosine, and the horizontal is going to get the sine. You see that? That's what I was wanting to work at. This one would be a positive number. This one would be a negative number because you're going to the left.
Right.
So we got to watch out for that kind of stuff. All right. So what is this velocity? This is A, Earth. So that's VAE, right? What else do we have? What's this one?
That is velocity of student B relative to student A.
Correct. And so once you get two of them, what's the next step in any relative velocity equation? Write down and give me an equation. Otherwise you can't solve anything, right? So what's the equation you would write down? Doesn't have to be the same one I would.
So it would be VAE plus VEA plus VBE.
Go ahead,
No,
try it. Anything will work. Okay. Go
I'm
ahead.
trying to do the. So we're trying to squeeze out the E.
So then just write that.
Okay, there you go.
And then what do you get left over?
VBA or VAB.
Which one?
VAB.
Right. So now notice this is exactly opposite what Jake did, but is that a problem? So rather than try to get it right, just write down anything. Do you agree this is a valid relative velocity equation? That's a valid equation. So then if you want, you could just make everything negative, right? And then you could flip the order as needed. So, right, if you flip the order, well, this says VBA is the opposite of what I just wrote, right? It would be negative VAE. And so use that trick of just, if you want to flip the subscripts to make them match, just start using negative signs. You know what I'm saying, Esteban?
Yeah.
And so rather than overthink it, just write any old valid equation, then use the minus sign to figure it out later. The other thing that you could do, Esteban, is this. What are we trying to find?
So we're trying to find VBE.
So you could write that on the left side and then say, okay, I know I need a B here and an E here, and I'll squeeze it out. A. Is that what you were trying to do in your head?
No, but that's a really good
Yeah,
way
and
to do it.
Then you're like, okay, well, this one, got it. BA, oh, got it. So that one happens to be a slightly faster way to do it. Is that good?
Yeah.
Jake, what do you think? Good?
Yeah. When you flip the signs, shouldn't the subscripts have flipped? Or am I?
Now notice, what did I do here? I flipped all of the
okay.
signs, and then I didn't flip the subscripts. So these ones became negative.
So you can do one or the other.
You could mix and match. You could go crazy. And so that's why it's so important to just get any old equation written down, and then you go play with the subscripts one at a time or all at a time, or do one or two or all three. You see what I'm saying? So because I stuck a negative on all of them, that's what allowed me to flip this one, but I didn't flip the subscripts on these, and I kept them negative. Good enough?
Okay.
And it's time to end, but I'll just keep going just for the hell of it. How about just for the halibut? I want all you can eat halibut. Okay. Oh, this looks like a problem. Okay, that looks like a 1D motion. This looks like some kind of, oh, look at this projectile problem. Looks like there's some conceptual questions here, right? Those are your favorite, right, Jake?
Yeah.
Yeah. So there's some good. So by doing these practice tests, you can see some of the ways I'll mix it up. So then, okay. Oh, how about this problem? Let's just skim it real quick. If you got to leave, take off, but I'm going to keep live streaming. If you want to just basically look at this, let's not set it all up, but just figure out what type of problem this is.
Well, it's not standard projectile. You can.
I like that
immediately.
So what would you do next?
Start writing the knowns and unknowns.
Okay. And then what's V initial Y?
Is it 0?
How do you know?
It says it's only moving horizontally.
Exactly. If it's moving horizontally, v initial y equals 0. And then I think we know v initial x in this case is now 778. I'm going to leave out the, okay. And then here's your acceleration. Here's AX, here's AY. We're doing a standard coordinate system. That doesn't mean it's a standard projectile, but we are using that. So it's 44 meters tall. What's the vertical displacement right before impact?
-44.
Nice. All right, you guys are there. All right, let's cut the live stream.